Hey guys, so my name is Stephen Tamman, and today I'm going to be going over the third part of our series here in learning how to program, how real software developers program. And the title for this time is going to be Why Learn How to Program. So we're going to kind of start from the basics here of, well, so you've heard about programming and software development, but why should you want to do it, right? If you're weighing this as a career path, as an option, maybe you're watching this series and you're not so dead set on becoming a programmer, you're kind of just curious about it. Well, today we're going to be going over why you might want to learn how to program. What's its utility? What's the purpose of spending time learning this skill? So here's the outline. Here's the things we're going to talk about. First, we're going to be addressing this point here. Should everyone learn how to program? Should we view it analogously to reading and writing? We're going to say that that's really not the case. There's certainly some specializations. For example, when I was at Georgia Tech, most of the engineers had a minor in computer science. It was super common. In fact, it was super hard to get into the CS department at Georgia Tech because so many people were minoring in it. Because we had all these guys who, well, if you're a mechanical engineer, you're going to need to interface with the hardware systems at some point, which means you probably kind of need to know how to code. And if you analyze data, that's why they taught us MATLAB at Georgia Tech, was because it's very data centric, and being able to deal with all that data as an engineer is super useful, right? I mean, I can say my dad's an engineer as well, and I know he uses MATLAB at work and stuff. I mean, of course, my dad learned how to program Fortran back when he was getting his graduate degrees way back when, but like MATLAB is super used. And so many engineers will also learn how to program, but certainly not everyone in the world. Like English majors don't need to know how to program, right? So there are definitely fields where it's useful, but we shouldn't overprescribe it, right? There's opportunity cost in that. Next, we're going to be talking about how computer science is not the same thing as programming. Some people tend to conflate these things. And unfortunately, like I already kind of railed against the very first video in this series, well, when you get a degree, there is no degree in programming in most colleges. So if you just want to learn the practical skill without getting all the theory, kind of tough out of luck, because that's just not how it works, which is kind of unfortunate in my opinion. But computer science is not the same thing as programming. So we're picking up the practical job skill here, the learning how to code, learning how to build stuff with software, rather than learning how computers work per se. And then after all that background, that's when we're going to dive into the real practical reasons as to why learn programming, why this is such a good career path, the cost benefit analysis sort of things that makes programming such an excellent field to study and such a good thing to put on your resume as a job skill here. So first, this question here, right? So should we view programming analogously to reading and writing? Is it really that useful? Should we say that everyone should do it? There's actually a video from this channel here, and I actually really like this channel, by the way, side note, Polymatter, some really interesting video about not everyone should code. So, I'm going to turn the volume off here, but, like video goes over a lot of the interest groups that might want us to code. So, like, for example, the government, it pays well, they get tax revenue. It's also in our national self-interest to have a lot of the software centers of the world come from the United States. So, for example, our tech companies like Facebook, Google, Apple, things like that, well, they're all based in the United States. And so that kind of gives our country disproportionate sway on the world stage in terms of technology. And also, of course, companies want us to learn how to program, because then it's a supply and demand thing. If there's more people who know how to program, well, then they get to be more picky in who they choose, and they get more qualified people applying for their jobs and stuff. That's really good for them. So the government and companies both will kind of encourage programming. It is very much something that's pushed in the education system. I went through the public education system. I'm telling you from experience here. Actually, I have no idea what it's like the last 10 years. I'm kind of old now, but at any rate, we have these people who it's in their best interest to encourage us to program. It isn't really a bad thing. I'm not saying, oh, shame on them, but they're just acting in their best self-interest. But at the same time, we shouldn't over-prescribe it. There is opportunity cost, as I say down here. There's opportunity cost in learning how to program, and it's not complicated. It's basically just, it's not a super trivial skill. To become very good at it, it's not like it takes a week or two. Now, there are programming coding boot camps. They do work okay. Like you can certainly pick up the basics in not so long a time. But if you're going to do it professionally, if you're going to do it in a sort of environment where you really need to be competent in a professional setting, well, then you do need to spend some time on it. And so coding, as we say here, is more domain specific than reading and writing. And if you want to see the full treatment, I referenced just a couple of things from this video. It's very, very good, very well made, has the pretty infographics that I'm not capable of making here. So you get slides if you go with me, but here you can go watch the pretty video He probably does a much better job explaining it than me here. But coding is more domain specific than reading and writing. So it's an excellent skill to have. And as I say here, I'm going to get up on my soapbox for a second, especially if you embrace its thought patterns. So there's this idea of encapsulating complexity, organizing larger problems into composed sets of smaller problems, that sort of thing. Well, if you carry that sort of thought forward into how you view the world, it can be super useful in organizing other things in life. I benefited from this a lot. Like I said, that's why I'm getting kind of preachy about it. Now, to be perfectly honest, this isn't just programming. All of this is really more related to the so-called engineering mindset, right? Rather than programming specifically. So dealing with large and complicated systems, understanding them holistically, understanding the system itself and what the system's mechanisms and interrelations are, and then breaking down said systems to manage complexity, right? Well, this is very much how engineers view the world. It's very useful. It's a very useful framework for understanding the complexity of this part of life. But all this aside, we really do need division of labor in the economy, right? Think classic Adam Smith in terms of economics, right? You do guns, I'll do butter, then we're both better off for it. Well, that sort of thing, division of labor, is what makes the world go round. And if everyone became programmers, well, what would happen to the engineers and the doctors and the accountants and the lawyers? And you get the idea, right? Because we really need different people to do different things in the economy. And just because of how supply and demand works, if suddenly we have all these people with this skill, well, it's going to kind of lessen the value of the skill, right? But the big reason here, and if there's only one thing to tell people, the big reason why not everyone should learn programming is because it's kind of hard. It's not something that you can just snap your fingers and pick up instantly. And you might say, well, we force everyone to learn how to read and write, but that has far-reaching consequences on everyone's lives, right? Literacy is such a huge important skill for us in our information age. Well, coding is just really not quite the same thing. It doesn't touch absolutely every aspect of your life like how reading and writing does. And so, as we say here, even though politicians and big tech companies might want everyone to learn how to code because it's in their best self-interest, well, we still should be careful not to force it upon people if it really wouldn't be best for them, right? It's a great thing. Like we said, we shouldn't minimize the practical benefits of it. And we'll get to some of those a little bit later on in our presentation here, but we just shouldn't try to force it upon everyone. Now, it might seem kind of strange to emphasize this point so much, but I've been around a number of people, even in my own personal life, who really seem to try to talk people into it, right? Convince skeptical parties that if you don't do this, you'll be missing out, almost like guilt tripping people. Rubs me really the wrong way. It's just really not right, because programming is great if you're interested in it. It can be a great boon to your career, even in many fields that you might not immediately see it in. Like I know there's a lot of doctors and stuff who are becoming more involved in it because it's super useful for their research. I can think of there's this crossover field called bioinformatics, which deals with statistics and computer programming in terms of big data sets and also biology and biochemistry. Well, all of that stuff is super useful, right? So programming, especially as computers come to dominate, is becoming increasingly involved in any number of fields, but that still doesn't mean that everyone has to code. Because if we have people who are doctors, well, they can be better doctors if they focus on doing the doctor things, and they leave the coding to people who are professional programmers. Now, I'm all for multidisciplinary studies and stuff. I mean, just look at me, not like I'm a perfect example here, but I have degrees in 3 different fields. So I studied a lot of different things in college. I mean, I took classes even outside of these things. I took classes in philosophy and business management, and calculus, and all this other stuff, right? So I certainly studied widely, and I think I got some value out of that. But the point that I'm making here is really that we do need division of labor. It makes us all more effective if people specialize and do the things that they're best at. And so we shouldn't throw that concept out the window in some misguided attempt to make everyone know how to code, because it's really not the same thing as some of the more fundamental core skills that we all really should learn as a society. All right, so second thing to handle then, having handled this a little bit about how not everyone should learn how to code, is, well, is computer science and programming, are these things the same? And fundamentally, these things are not the same. So computer science is not the same thing as programming. And if we're being a little bit hand wavy here, programming is to computer science kind of as engineering is to physics. So it's the practical, not the theoretical arm of the subject. Now, of course, there's applied physics and theoretical physics, but leave that aside for a second. Engineering is basically applied physics, and programming is basically applied computer science. So in practice, this means that it's much, much easier to teach people how to code than it is to teach them exactly how that code works. So for example, how code gets translated from a high-level language with a just-in-time compiler into CPU-specific assembly with an operating system's kernel, parallelizing computational load across multiple processor cores, et cetera, right? That's even just that right there is actually a pretty high-level overview, not getting into the messy details of it, but put simply, things like that. You really don't need to know those things. You don't need to know about algorithmic complexity or dynamic programming and building dynamic programming tables, or how binary works, or the CPU pipelining behind efficient floating point multiplication, or any other things like these to write code that makes stuff, right? Like application levels, building software for clients sort of thing. So some people need to know these things. Some people certainly do. The people who build computer systems, who build the hardware software interfaces and some of the libraries and packages we use, well, those really smart people, well, they need to know these things. But do we? Does everyone? And so my opinion, as you've no doubt gotten from previous videos in this series, is that not nearly as many people need to know these sorts of things as are forced to learn these things by arbitrary educational requirements. So all this theory stuff, how all of the operating systems and compilers and stuff work at a low level, well, some people need to know those things, but I think we shouldn't make everyone do it. So for all these reasons, we're going to be specifically looking at the question of why learn programming rather than why learn computer science. Because in my opinion, learning computer science is very, very useful for a certain small subset of people, but it's a lot more narrow in focus than programming in general. And if you want to work in industry, if you want to get a job out of programming, make a career out of it rather than becoming an academic and staying in academia, which is really more properly where computer science happens a lot of the time. Not that there aren't like research centers and stuff. I have a friend who works for Research Institute in the government. He does research basically, taxpayer funded sort of stuff for the Department of Defense and really cool like malware analysis, that sort of thing. But so there are like research institutes independent from academia, but they're kind of like related to academia is the point that I'm making here. Well, if you want to be in industry, then learning programming is what you're after, not learning computer science per se. I mean, you need a little bit of computer science to understand some of programming, but by and large, programming is a skill. It's a practical arm of computer science, which is where some of the theory is. So we're going to be answering the question based on all of this of why learn programming rather than why learn computer science, really. Because for most people who want to use programming as a way to boost their career and become a more valuable employee and be able to do more for their company or just have more opportunities and that sort of thing, really what we're after is learning how to code rather than understanding all of the complicated mechanisms behind how that code works, at least at a high level. All right, so with all that background out of the way, we're now going to turn our focus here to the question of, well, why learn programming, right? Why learn programming as opposed to choosing another career field? Why is it something that's worthy of our time and our attention? So the biggest reason here, and this is really what drives everything else, is that programming is a skill in very, very high demand. So from the Bureau of Labor Statistics, it has one of the highest job growths out of all fields across all professions. It is in very, very high demand, and it has been increasing for a while now. So this fact right here, which as I say is really what drives everything else, it gives it a couple very large benefits simply due to the mechanics of supply and demand. So the first one here is that salaries are high, right? Well, if there's a supply crunch, well then demand exceeds supply. Well, that's a good thing if you're one of the people in high demand. So salaries are high for us, over $80,000 on average. Right? We're talking like median, depends quite a bit on where you live. So cost of living factors matter a lot. Like the poverty line in like Bay Area, San Francisco is super high, like $80,000, $90,000 or whatever. So to actually earn a good living there, you have to be paid well over six figures, and maybe $120,000, $130,000, $130,000 a year just to make a good living there. But if you're in a lower cost of living place, maybe you only get paid $80,000, and you have to compare apples to apples. So you have to subtract cost of living and higher taxes from being in that higher tax bracket and all that great stuff. But nonetheless, even given all of that, right? So when we say average $80,000 a year salary, well, that's still super high, right? Very, very high, even when you adjust for all that, especially given the relatively low level of education required. So even though I've been harping on how I think a lot of computer science education isn't useful for programmers and stuff, well, most of the time, for most employees, you still kind of need a college degree for it. At least I did in my job. The employment requirement wasn't like knows C# API and Angular, but the employment requirement was has a college degree in a technical field, which again, I have opinions about this, but that's just kind of the reality as it is. But nonetheless, You spend 4 years at an undergraduate institution getting a bachelor's degree in computer science or something related, and then suddenly all of these career opportunities open up to you, right? Salaries over $80,000 a year, right? That's a lot. When you look at the average salaries for most jobs across the rest of the economy, this is huge. This is super duper high, and you only need an undergraduate college degree. So some of the highest paying jobs, people who are what we call professionals. So accountants, they have to go get their CPA license. They have extra stuff, right? Doctors who get paid way, probably some of the highest paid people across the entire economy. Well, they have a ton of education they have to do. Lawyers as well, they have to go to law school. You get the idea, right? But us as computer programmers, we just got to go spend four years, or maybe 3 if you're fast and you come in with some college credit already from AP classes or dual enrolling in high school or whatever. Well, maybe you get out in 3 years and suddenly you make $60,000, $70,000 as your starting salary, right? That is one of the benefits here to learning programming, is because it's such a skill in high demand, you get paid a lot because you're in demand, because we have a shortage of this in the job market. So on top of already having high salaries, well, you won't struggle to find a job, right? And in particular here, it's not just finding any old job, but finding a job that you're actually fired up about, someplace you want to work, someplace you want to be, rather than just taking one for practical reasons. So you'll be able to pick your company more, since you'll have more people interested in you. Because as I say, demand outstrips supply, which is very good for you as someone going into this field. So you might need to have a 4.0 GPA in a less in-demand field to be competitive in the labor market. But for computer science, maybe you only need a 3.2 GPA if you're in programming, because, well, we're in such high demand that even people who aren't quite as good at it as the hot shots, well, as long as you're still competent, plenty of companies will still want you because it's such an important skill. While if you're in something that has much more of a labor squeeze because supply outstrips demand, actually, this is a huge problem in academia, for example. Like if you want to go get hired as a professor somewhere, there's a lot of competition for it. Well, but as a computer scientist, you don't have to worry so much about that, because as long as you're competent, as long as you try, you put in your best, and you graduate, and you're basically a functional programmer, you don't have to be the best of the best to get a good job, and even to be fought over by companies to get a job, because demand is actually that high. So these are the benefits that are mostly driven by this supply and demand thing, this idea of programmers, because computers are playing such a big role in our lives now. Programmers are going to be in high demand. There's a couple other benefits to programming relative to other things. And so this one is actually kind of an interesting consideration here. Because programmers are needed to develop the software that runs computers, we're actually only going to experience more and more growth here. And because computers keep taking over ever greater sections of our lives and our economies, automation has really revolutionized manufacturing, for example, and AI type stuff is starting to get involved in farming, and you get the idea, right? Computers are everywhere and they're not going away anytime soon. So programmers, people who deal with making computers do stuff, well, they're going to keep being in higher and higher demand as computers keep taking on a higher and higher role and more things in our society. And actually, rather than facing pressures in the future due to having jobs replaced by computers and automation, so this is actually a serious threat to the livelihoods of many career paths, is that as computers come to replace human workers, well, a lot of human workers get displaced. Skilled labor is suddenly being taken over by automation. Well, then suddenly you're out of job. And so that is the opposite for us, because to make that automation happen, you need more software developers, you need more programmers. So demand for programmers will actually go up because of all this automation, not go down. And that makes it rather unique in the labor field, because many other things will eventually in time, especially as AI gets better, especially as automation improves, will come to be replaced by computers in large part. Maybe not entirely. Many things it's very difficult to do entirely because, despite the movies, AI is actually very, very challenging to program in a completely efficient manner. But nonetheless, automation will put a job squeeze on many different career fields. But programming, rather than having that problem, we're actually the opposite, because you need more and more software developers to be able to manage the complicated software, hardware systems that are necessary for all of this. So it will actually only increase demand for us over time. Again, and demand has all sorts of benefits for us as programmers, right? Higher salaries, easier time getting a job we actually like, things like that. Well, that's going to keep being the case, because we're going to keep being in demand, just because that's the direction the technology is trending here. This one is a little bit less related to career stuff, but it's more just on a personal level. Programming knowledge is actually super helpful when you're setting up a website. Now, I'm kind of biased here. I run two, but I think that websites are super useful for most people. It gives you an outlet, creative outlet for yourself, lets you share your views with the world, that sort of thing. Now, you can set up a much better website if you have some programming experience than if you don't. Blogging templates make it kind of easy, but if you want to do things really well, or you want to do anything fancier, well, then being a programmer has advantages in that. Also personal projects, not just websites. I have several personal projects that I was very interested in. And actually, this is one of the main reasons why I personally decided to learn programming, was because I wanted to be able to do this stuff. And I knew I couldn't do it unless I got some software experience. So personal projects, websites, also something that you get out of learning how to program as a skill, right? Completely independent from your career, actually. But I think it can be very useful on a personal level because you can suddenly do things that you couldn't do before. So the basic gist of it, and the reason why programming is such a great thing to learn on a practical level. Now, I could get on my soapbox and tell you how it changes your way of thinking, and I kind of mentioned this engineering mindset business already, but most people watching this are really probably interested in it professionally as a career sort of choice. And in terms of that line of thought, there's actually very few jobs that will give you more bang for your buck in terms of value per unit preparation, time, and money. So how much you have to spend preparing versus what you get out of it. Think return on investment, right? There's very few jobs that will give you more bang for your buck. And that's the primary practical reason to learn programming, is out of all things in the labor market, you are picking one of the fields that has the best prospects, the best practical outcomes here. So based on this return on investment, risk analysis, and job stability, and so on, other things like these, I really don't think that I could recommend many things that would rank higher than programming, even if I wanted to. So even if I was personally biased towards something else, the facts don't lie, the statistics don't lie. Programming is one of the very best career paths that you can take just because of all of the factors that we've discussed that make it in high demand and that will make it continue to be in ever increasing high demand. So if you absolutely, you pointed a gun at my head and you made me pick other fields as alternatives, right? Things that I'd recommend alongside programming. This is kind of a side note here just to close this off. So fields with similarly good cost benefit outcomes. I'd probably suggest engineering and IT. Both of these things you can also get away with just a simple undergraduate degree, and they also both get paid disproportionately well, right? As opposed to some of those other fields that we talked about, like doctors who have to go spend 8 years or whatever in medical school and residencies and stuff before they can finally start making money. Well, as an engineer or an IT person, you can make quite a bit of money right out of college with just an undergraduate degree, and maybe even an associate's degree for IT, kind of depends where you work. And so these are other good fields, but I think even these fields aren't as good as programming because of some of the reasons we've talked about here, especially just given how dominant computers are and how dominant they will continue to be. Programmers have it even better because we're in even higher demand in these fields. But if you want alternatives, you might take a look at these areas. Engineering is very fascinating. I spent several years of my life studying it before I became a computer scientist. So of course I'm biased there too as well, but there you go. So this has been my thoughts here, my meditations on why learn programming, right? Specifically from that practical perspective, why learn it as a career move versus perhaps more philosophically why learn it. I'm not going to get up on my soapbox and say that learning how to code makes you think in terms of algorithms and will change your life and all that. It's great. I really do feel like it shaped my worldview some, and it can be very useful in helping you organize your thought and things like that. But I really think the main thing that should drive you to learn how to program, if you want to do it as a career, is just the practical considerations. Some of these things we've talked about here in terms of supply and demand that make programming such a great skill to learn from a professional context. So this is what we talked about. This time we started off kind of knocking down that idea that everyone should learn how to program, because it really is a specialized skill that has opportunity cost in terms of learning it. So it's not quite the same as reading and writing because it's only useful in some circumstances. And even though the government and some tech companies might want more people to learn because it's better for those entities' self-interest, well, from our perspective, division of labor is super important in the economy. It's not something that we should overprescribe to people because there's opportunity cost in doing so. So after that, we talked about how computer science and programming aren't really the same thing, and how really what most people are interested in our discussion here is going to be programming. It's going to be the practical side of things, not the theoretical, right? In the same way that engineering is what companies are more interested in rather than some of the physics that underpins it. Well, so too for us in programming. And that's really why we're answering the question here of why programming, why learn how to code and learn this practical arm of this skill here. And then we talked about how we have all of these factors in the job market that make it so beneficial. and why this is such a good opportunity for people because of some of these factors in the future of how computers will continue to be used ever more and how that kind of guarantees your job security as a software developer. So that was our things today. Actually, next time, we'll be going over some of the options for career paths in programming. So having established that programming gives you great career options, we'll be going through what some of those options are. And in my opinion, what some of the best things to think are, like what you should put your focus on in that. So stay tuned because that's what we'll be talking about next time.